Alright, let's begin. So for today's lecture, first I will make a correction for the practice or the hands-on homework that we mentioned 2 days ago, and then go through the demo for setting it up, and then once we're done with that, we will then continue our discussion on TDD or test-driven development. We'll finish the remaining videos, and then I believe we'll have quite some time remaining, and we'll use that time to look at the software project from another perspective, which is from the PM or project management perspective. So yeah, we'll just talk about that later, and then we will be using learning materials from another open course that's on Coursera. So later I'll show you the link of that. So now let's get into today's subjects. So first is the correction for the homework. So basically, last time I pasted the wrong link for that GitHub repo. I've already made the correction in our popular course. Now, if you click on that assignment, the link in the description should lead you to the correct code repo. And if you click that, you'll get to the GitHub page, and as always, fork it and clone it. And then probably you've done that a couple of times. Once you CD, okay, so one more folder. Once you CD into that, you will either see, you'll probably see a warning saying that the Ruby version doesn't really match, and then it will give you the command to install the right version of Ruby, but I've already done that, so I don't see that warning. So it's already looked up the Ruby version and then switched to 2.3. You are probably on the same version if you follow the steps. And next, same thing. Use bundler to install the dependencies, and you will see that it says there is a failure due to some incompatibility issue. What you need to do is basically remove that offending gem in the gem file. So now I'm just editing that gem file. The one that's complaining about is sendTest. This is actually not really required for this homework, so you can just delete that line, save the file, run bundle install again. Again, since I've already installed that, everything is already installed, so it returns in a second. For you, it may take a minute or something like that, a while for it to complete the install. And then next, again, just follow the instruction according to the README. Execute, rack DB migrate, it will set up the DB the database for development, and then you would see a warning saying this thing is deprecated. It's totally fine. It's just because this repo is using a pretty old Ruby version. And the next command to set up the test database. You probably will see the same deprecation warning. It's totally fine. So we have both the dev environment and then test environment database set up. Next would be creating a file in this directory. So we'll go ahead and do that. It's actually optional, but you can read the description. Basically, it helps to prevent some deprecation warning. So since it's pretty straightforward, we'll just go ahead and do that. RP, paste everything in there. And we should be good to go. So just to test everything is okay, what you need to do is run bundle execute rspect. Because we have not written any unit test yet, it will succeed, saying basically no test found, so nothing failed, so let's see. Same thing for Cucumber. Bundle execute Cucumber. There are some scenarios already in place for Cucumber, so most likely you'll see a bunch of grain which should already pass, and some skipped stuff. and if you see all these, then the setup is good. You can then continue with this assignment. And then what you are asked to do is describe, starting from part 1 in the README file. Basically, you are asked to add 3 more features, and the description of the feature, some are here, and then others are already added into the Cucumber feature files. So you could also look it up to understand what's the feature that you need to add. And then during the process, you're also supposed to implement unit tests while you're working on the features. So like in the videos, we've talked about red-green refactor. We follow in this assignment, basically try to follow the same process. Write the Cucumber tests, it should fail, it will be red, and then write the unit test that hopefully handle the first step for that function or some component for that functionality. Write the rspect test, it should also be red. At the beginning it should fail, and then you write the implementation, write the code to actually implement it, then it should pass, you got green, and then just continue that cycle. And then once you're done with that, commit it and push it to GitHub and submit the link. Alright, so that's the correction for this week's homework. Let me close that. Close that. Okay. Right, now we will get into the content for today. So there are a couple of more videos we haven't finished watching yet, so we will do that first. You can also find the same content in the same video in the edX course.
Okay, so that's where we are. As a brief review, when we started talking about generally testing any kind of application, but certainly software as a service, we have spent the last week or so talking about integration tests, also called full stack tests, also potentially called acceptance tests if the test is based on a user story that came out of a customer meeting. And basically, those, as you've seen, are a description of a complete workflow to accomplish some task or some subset of a task. That means that typically, in terms of your app, a single integration or full stack test is going to include a number of HTTP requests back and forth or a number of interactions between the user and the app. We have not yet talked very much about module or functional tests, which is behavior that doesn't necessarily take a lot of different steps from the user's point of view, but it does touch a lot of different parts of the code. So for example, thinking about what happens when a route hits your controller, right? Get or post with some URI. Your controller has some code that will run. Maybe that code does something with the model and with the database, maybe not. And then at the end, it probably will either redirect or render some kind of a view back to the user. So that's still only one interaction, but it touches a controller, it touches routing, it touches the model, it might touch view rendering. So it's less than a full scenario, but it's more than a unit test, right? Because many moving parts have to work together. And a key concept we'll talk about in those tests is how do you test reliably when you've got things that depend on each other? How do you test something in isolation when it depends on other things? And unit tests are the kind that when you have to write sort of simple tests in lower division courses and stuff, they probably tend to be more like this. You're usually testing a single method or function or maybe a single class. And you're checking that the behavior of a single method does what you expect. And in the simplest possible case, if the method is a pure function where it has no side effects, you just pass it some arguments and you want to see if the right answer pops out, those are kind of the simplest tests to write. And then we're going to show what other mechanisms you can use to do tests that are more sophisticated from there. Okay, so this is where we are. And we're going to use a tool called RSpec, which is, if you've used JUnit or any of the sort of Java testing tools, it sort of comes from that family. But I think it's actually a lot more streamlined and graceful to use. Is how much is enough? How thorough is your testing? And this turns out to be maybe not as obvious a question to answer as you might think. So how do you know when you're done testing? How much testing is enough? Once again, there is no single formula cut and dried answer, but there is a lot we can say about bad practices and good practices. A bad practice is until it's time to ship. By the time shipping date comes, that's enough testing. We've probably all used products that seem to have been tested this way. OK, what's sort of the next simplest thing that you could imagine measuring? Well, there's the test-to-code ratio, which is just in the entire code base, how many lines of tests are there versus how many lines of app code. It might surprise you that in many cases, there are more lines of tests than there are lines of code. Or maybe it doesn't surprise you. But a well-tested app, like in a production system, a factor of 10 for that number is not unusual. That there are 10 times as many lines of testing as there are lines of code. And intuitively, I think of the reason as there's only one way for your app to behave correctly, but there's many ways that it can go wrong. So it shouldn't be surprising that you're essentially trying to exercise many different ways that it could go wrong. That means you have a lot of test code. You've got a lot of cases looking at different specific behaviors. So this is still a static measurement, though. It doesn't really say anything about what the tests are doing. So a better question might be, could I evaluate either through some formal method, like can I prove what aspects of the app are being exercised or not exercised by certain tests? So meaning without executing the test, I can prove formally what parts of the code are going to be visited. And we'll talk about different ways that we might think of what coverage means. We're going to focus mostly on non-formal methods. And by non-formal, I don't mean informal, but I mean empirical. So we're not going to prove things about whether a particular behavior of the app has been exercised, but we are able to measure some things about, in general, how much of the app's functionality is probably being exercised by tests. So here's a simple function. Actually, it's two simple functions. One is called foo and one is called bar, which once again demonstrates the extreme poverty of my imagination. And you can see that down here, foo calls bar. This function obviously doesn't do anything very useful, but I want to use it to talk about coverage and why coverage is maybe not as obvious as it seems. So if we want to say, we would like to have tests that completely cover these two functions, foo and bar. What does completely cover mean in this case? What are some possible, like, what is a baseline meaning for completely covered? Yes? So one possibility is exhausting all tuples of these inputs, x, y, and z. Let's say for the sake of argument that x, y, and z are 32-bit integers or something. Hopefully you believe me if I say probably not practical to try every single combination of three 32-bit ints. But we could talk about values that might cause changes in the code, right? So clearly some values for x will cause you to go down this branch of the if versus that one. What's an even simpler metric than that? Yes?
Has every line been visited?
Has every line been, so the simplest is did I call foo, did I call bar? The next one is have I called foo and bar from every place from which they could be called? And the one that, remind me of your name?
Homi.
The one that Homi just said is basically, have I at least executed every statement once? Have I touched every line, basically? Okay? And the gem that we'll be using for a lot of our coverage called SimpleCov, basically that's what it measures. Have you touched every line? There are other measures of coverage that go beyond that. C1 coverage says you've taken every branch in both directions. So notice that C0 in this case, here's a one-line if. C0 just says this line was touched. But it doesn't necessarily say that both clauses of the if were touched. Now, in this particular example, we sort of end up having no choice, because in order for bar to get called, you have to have done this side of the if. But in general, C0 doesn't ask if every branch was taken in both directions. It just asks whether every branch was attempted, right? You got to the if. C1 says, make sure you've taken every branch in both directions. And you can go farther and say C1 plus decision coverage. So not only does this branch have to take both the if path and the else path, but in evaluating the if path, we have to look at every combination of y and z that could make this if go either way. So basically every sub-expression within a conditional. That's C1 plus decisions. And C2 is really hard. C2 is every code path possible. So starting from the entry into foo with particular values of x, y, and z, taking the path where this if is true and this if is true is a path. The path where this if is true but this one is false is a different path. The path where this one is false, and you get the idea, right? And in an entire program, or even for an entire function, this can get very hairy very fast. And there is not necessarily widespread agreement that C2 buys you a whole lot more than these levels in here. So for the purposes of this course, and sort of as a good rule of thumb, if your C0 coverage is really high, and it's quite easy to measure, and it doesn't cost much to measure it, that's kind of what we're going to use as our baseline. But be aware that talking about this, code coverage is actually way more complicated. Another type of coverage, which we won't discuss here, is called define and use coverage. So, here's x, and somewhere before this, somebody called foo with a value for x. Where did x originally get defined? Like, what's the last value of x that was assigned that's going to make it into this function? And the more exhaustive version of that is I'm going to look at every pair of places where x is set to a value and later x is consumed by someone. So look at every pair of places where those things happen. They're called define and use pairs. So you can go really nuts about this. But I think for the purposes of this course, let's focus on C0 coverage. Every statement has at least been touched. Going to extremes about testing. Obviously, things like, I kick the tires and it works. This is what a lot of people who don't have any formal software for anything think of as testing. They put their code into a browser, they try a couple of test cases, looks good to me, and then they ship it. And then we end up with what happened with Obamacare when it was rolled out in 2008. Don't ship until it's 100% covered. 100% coverage is actually tricky to get, and how much better that is than like 96% coverage, it's not clear. So again, it's really a matter of what are the guidelines that you're using to ask yourself, well, if I have low coverage, where is the coverage lowest? Like, is my coverage 96%? because I have one function that isn't touched at all? Or is it because all the functions are mostly covered? So really, you're using coverage as a tool. It's not, you're not using coverage as a threshold for go or no go. You're using it as a signal back to yourself to say, OK, where could my coverage be better? And maybe the places where my coverage could be better are actually pretty important, and they're under-tested. Likewise, some people say unit tests are more thorough because you can stub things out and focus on specific cases. Other people say integration tests are more important because they're more realistic. They behave the way a user would behave. I would not go to extremes on either of those. The question is, what's the right balance between them? And in practice, each is going to find bugs that are missed by the other. Right? In unit tests, because we're stubbing out all of the interactions, there may be bugs related to those interfaces that we're going to miss. And in integration tests, because we're taking one code path through every layer of the app, there's a whole bunch of things that could happen at each step that are not going to get covered. So they're going to miss a bunch of corner cases. So the general question is, we had this as one of the clicker questions last time, right? Are you testing an entire workflow? Are you testing one interaction, one method? Having a balance of different tests and sort of aiming for high coverage across all categories is your friend. And when you're doing deployment of the projects, we will help you get set up so that every time you basically do a push to GitHub, even if you're developing a branch, you'll be able to run all your tests and get instantaneous or almost instantaneous information about coverage and look literally line by line in your app at which lines of your app were never hit by any test. Okay, so good times. We've talked a little bit about the kinds of tests, but now we can kind of put them on the spectrum, right? We've seen things that are more like unit tests, where you're focusing on a particular method, functional or module tests, where you touch a few methods or classes, and integration or system level tests. Unit tests tend to run really fast because they don't have to do a lot of setup. Integration tests like Cucumber tend to run slower. Why? Because it has to fire up the entire app, right? When you do a Cucumber scenario, it has to stand up your entire app so that it will behave the way that it would with a real user. When you're doing a unit test of one method, it just has to load that method. So unit tests tend to run faster per test, although the amount of code that they cover is smaller. Similarly, with unit tests, you can get very precise resolution. If you want to target a particular rare corner case, what happens when these inputs have these values, it's often much easier because you can isolate unit tests so well to do that kind of thing in a unit test rather than doing it in a coarse-grained scenario. And you can usually boost your coverage better by writing more unit tests for the same reason, right? If there are code paths that are only exercised in rare situations or only exercised if the user makes a certain type of error when interacting with the app, it may be clumsy to write Cucumber scenarios that go to all those places, right? It's kind of like having a really coarse-grained stick and trying to pull an insect out of a hole or something. So having your scenarios there to test the main happy paths, the main common sad paths, but then having a bunch of extra tests at the unit or module level to sort of fill in those blanks, right? To get to the parts of the code that are harder to reach. Kind of like a toothbrush.
Right, so that's the discussion about how many tests are enough, like different measurements for like test coverage, that. And we'll go to the next one.
A word from our sponsor, and that sponsor is me. But it's also students who took CS 169 before you, because like I've said, a lot of the so-called advice that we give really is from them and not from you. And it's basically this very funky idea that we're introducing you to of either start with the test, like write the test before any code, or at least be working on them together. So like you write a line or two of code, then you immediately write a line or two of test to check it before you write any more code. For most people, the first time they do this, it feels weird. It feels like standing on your head or something like that. So this is one of the things that we asked CS 169 students about. Did you actually kind of work at it to get comfortable with this way of developing? And if so, how did you feel it went? Did it help you? Did it hurt you? What would you advise your peers to do? So here's the way I used to write code and debug. Maybe a lot of you do the same thing. You start out by writing a bunch of code, maybe a couple of tens of lines. You're a good coder, so you're sure it's right. But it's not, because when you run it, something goes wrong. So You kind of drop into the debugger. If the debugger is not helpful, you start putting print statements everywhere so you can print out the values of things at different points and see where it made its first mistake. If the debugger is helpful, you stop in there and, oh, OK, here's the problem. And you kind of make some changes while you're in the debugger to see, if I make this change, does that fix it? And then, like, no, it doesn't fix it. And basically, you keep repeating this non-productive cycle until eventually you get the code to work, and then you are so ready for a drink. That's the way that I basically used to write code. My life has been turned around by TDD, and I hope yours will be too, because it requires all of the same skills. There's nothing about TDD that you don't sort of already know how to do. You just haven't done it in this order. Instead of writing a lot of lines, you write the fewest lines possible. And in fact, you write the test first or in conjunction with. And you're just testing one little thing about that behavior, just one thing. And if you break something, you'll know right away which 2 lines it was that broke it, because you just wrote those 2 lines. It was working before. Instead of putting printfs everywhere, you have expectations. The expectation says, when I look at this value, it should have this other value, or it should match this regex, or whatever. So instead of having printfs, you have your test tell you the answer to that. Instead of stopping in the debugger and saying, OK, I'm in the debugger, and I need the code to go down this path, so I'm going to force this function to return some other value to make sure the if statement goes the way I need it to go. Well, that's exactly what seams are for. You set up a seam in advance so that, for example, the return value of a function or some value of a variable will give, you can control exactly what that is, and you can force the code to go the way you want it to go. And if, despite your best efforts, it doesn't work, you just press a button and run the same test again. You change your code a little bit, and you press the button. You change your code a little bit, and you press the button. And in fact, if you use tools like guard, which we're going to show you how to use for your project, you don't even have to press the button. Every time you change your code, it reruns the test that that code is associated with. So all of the same abilities that you use in debugging are the ones that you use in TDD. It's just a lot easier once you get used to doing it. So it's more productive once you get used to it. It will keep your tests independent. And by the way, once you're done with this process, like, oh, you have a test, right? You got a test for free. So it takes more time up front when you start doing it. But most students have found, and I have definitely found in my own practice, it takes less time overall. You will bang your head against things much less frequently if you can get comfortable doing things in this way. So this is one of these, it's going to feel weird the first time you do it. Stick with us. When students were asked about this, the students who brought it up as advice for their future peers, everybody agrees that it is weird at first, but it gets easier. It let you notice bugs faster, and because you were making small changes when you did have a bug, they tended to be easier to find and fix. This is the big thing that I've found, by the way. It's great that you come out of this having free tests, but the real aspect that I think is valuable and is overlooked is if you can write your function in a way that each individual behavior is testable, that's actually a really good function. Most functions aren't that well written. So it helps you organize your code and organize your thoughts. The teams that didn't do it or the students that didn't do it basically wish they had, whether that's not doing TDD or just not having enough tests. There is no worse feeling in the universe. Well, there are probably some worse feelings, but it's a pretty crappy feeling when your customer tells you, hey, I just tried this and I got like an error screen. And it feels so embarrassing. And often it's a silly error. In fact, the kind of error that could have probably been avoided with judicious use of TDD and good test coverage. So if there was a way to sort of help you see that value without having the pain of getting a puzzled phone call from a customer, I would do that. But I don't know if there is. What about dealing with test coverage? Like I said, we're going to set you up so that every time you push to GitHub, not only do your tests get run, but it's going to measure how much C0 coverage you're getting. The teams that had good coverage felt confident that when they developed new features, they weren't breaking stuff that used to work. Code Climate, which we're going to use, that's a tool that runs a bunch of different stylistic analyses on your code and tells you sort of how idiomatic and easy to understand your code would be for another person. It is super, super cool. And when you get a high grade from Code Climate, you're like, yes, I wrote code that is not only functional, but it's beautiful. It does the right thing, and another programmer could understand it. We're going to encourage everyone to use this model of doing a pull request, which is when you basically say to your team, my code's ready for merging. Please look it over and make some comments before I complete the merge. You basically, multiple eyeballs on the code will help find problems that could be avoided later. And again, the teams that had not committed to doing it this way ultimately wish that they had done it sooner. It's much easier to get into this mindset early on. So again, these are unredacted comments pulled from students who were sitting not in this room, but in a morally equivalent room like a year ago today.
Okay, so I do have some more comments on that video, but we'll finish the last video, then revisit on that.
A few last words about testing from the plan and document perspective. We added a lot of stuff about the plan and document perspective recently in the book because we wanted to make sure that we're not perceived as sending the message that Agile is always the right way to do things and it's the only way to do things. So in fact, there's a lot of testing activity in plan and document. In fact, one of the criticisms of plan and document in a classroom setting is that people feel that there's so much of that they don't get to actually write any code. But we've seen that in the BDD, TDD, Agile, Extreme approach, we write the test before the code. We start from user stories. The developers are responsible for, generally speaking, for writing tests that go along with their own code. So the question is, what happens in a plan and document setting for these same tasks? Well, there's a very important role in the P&D family of approaches is that there's a project manager who documents the project management plan, which includes a software requirements spec, SRS. And in case you were wondering, yes, there's a standard for how you write an SRS. The standard itself is actually tens of pages. But the SRS is enormous. And the idea is that that captures the requirements. It captures the test plan. And then once you've got this overall plan, you're going to now divide the plan into programming units and essentially assign different teams to work on each unit. So teams of different developers are assigned to different units. They do their own unit testing, but when it comes to sort of putting a lot of pieces together and doing system and integration tests, there's often a separate QA team that does that. And there's different ways that the QA team can do its job. One way is you try to do top-down integration. So this is more like what we think of as user stories, where you look at the top level or the customer's view as what the app should do, and that drives you to get some of the customer-facing functionality working early on so you can start testing it. On the other hand, it means you have to do a lot of stubbing below that level so that the customer-facing things have something to do, right? It's the equivalent of doing a wireframe, but with code. You could also go the other way and say, well, we're going to build out the pieces, and we're going to sort of test as we go and as we put the pieces together, but that means that the customer-facing part actually might not be testable for quite some time. But in this approach, you have the benefit that you're relying a lot less on stubs, right? As we all know, the problem with relying on stubs is if the stubs get out of sync with reality, then your stubbed tests will all be passing, but the reality may turn out to be that they fail. So the downside of the second approach is it's very late in the game before you can really put the pieces together and start getting rid of the stubs. So sandwich integration tries to go from both ends, right? You sort of work downwards from the customer-facing stuff and stub where you need. You work upwards from the unit tests, and you sort of start putting modules together. And the idea is that at any given point in time, you have at least some customer-facing things that actually might talk to real app code. The rest of them are being stubbed, but they're kind of working toward each other, right? It's like digging a tunnel from both ends. So you try to get it both ways. When you're ready to do the more serious testing, you sort of turn it over to the QA team. They're the ones who are doing the system test, and at this point, they're really testing the whole app. They're also testing non-functional requirements, which we're going to talk about when we talk about operations. So things like performance. Are there performance targets they have to meet? Targets of robustness in terms of defending the data in the app against malicious attacks. And how do they know when they're done? Well, it depends on the project. In some cases, it's based on things like coverage and metrics. We saw different versions of coverage that are not only about the control paths followed, but things like define and use coverage, which talk about data production and data consumption. So have you tested all of those paths? And once the QA team has sort of signed off, now the customer gets to test it. So you can see why the Agile methodology tends to put the customer first, right? The amount of work that has happened by the time the user acceptance test comes is pretty much everything in the project, right? So the assumption is the customer is going to like it by the time it's done, right? This is the validation versus verification. Did I build the right thing as opposed to did I just build the thing right? And it may turn out that in the user acceptance test, the customer changes their mind. So again, it's not that Agile is good for all projects, and it's not that Agile does things fundamentally differently in terms of which tasks are involved compared to plan and document, but the tasks are factored into a different order, and you carve them off in small chunks. So you do use mocks, you do write unit tests, you do write integration tests, you do put the product in front of the customer, but you do that for small slices at a time, and then you come back and do another slice. As we all know, we saw very early on that testing can be used to show the presence of bugs, but never the absence of bugs.
So again, what do we do when we can't do testing? Well, formal methods have been, yeah, I know, Dave made the animations for these slides. I can't take credit for the happy dancing robots. But formal methods are a completely different approach to program correctness. Basically, testing is about engineering, right? Testing is you've got this code artifact and you want to see what it does. Formal methods actually take a formal representation of the program and they try to prove some things just based on the formal specification. For example, you might want to guarantee that it can never enter a certain state. And in fact, this is gaining traction in industry in both hardware and software. Even as late as last decade, Intel, for example, was using formal verification to model the bus protocols for their multiprocessor systems. Because what you want to do is prove that, for example, you can never have a sequence of events that results in a bus deadlock. Now, there's a big issue, which is that often the formal spec is not necessarily a thing from which you can generate program code. So you may have proven that the formal spec is correct in the sense that it never goes into these bad states, but you still have to prove that the thing that gets built also follows the formal spec, and that's a different problem. So a human might be able to do these proofs, but more commonly computers do them using theorem proving. You can also do model checking, which is a combination of symbolic execution and checking to whether what sequence of states might be reachable depending on input values and control paths. But these are pretty computationally expensive, so they tend to be used on smaller size systems, on systems that are expensive to repair because, for example, they might be out in space or they're difficult to test. Safety critical software systems are usually a good candidate for these. And just to give you some metrics, the largest project that I know about that's been formally verified is the L4 operating system kernel. That's about 10,000 lines of code, and the research effort required comes out to about $500 per line of code. NASA has managed to beat that. The space shuttle software costs about $80 per line of code per year to maintain. It doesn't change very much, and the process for changing it is extremely heavyweight, but there has never really been a software failure in the space shuttle program ever. So the methods do work if you apply them correctly. Since we're doing software that is relatively easy to change, easy to repair, and relatively easy to test, we won't be doing very much in terms of formal methods. But I would say if you're going into the software engineering field, within 5 years, you can expect these to be widely used across many companies. So kind of summing up, in the plan and document world and versus the Agile world, we actually are doing all of the same things. We're creating customer specs, user stories, and so forth, but the order in which we do them is really what's different, and the teams, how the teams are factored to do them. Rather than sort of having a top-down plan and a project manager, we're doing things piece by piece and row by row.
All right, so that's about it for TDD. And so just a quick recap. When we talk about TDD, we're actually talking about two things. The first is testing, and the second is do the testing first, right? And then regardless of whether you want to do a test or not, whether you do a test first or do a test later, there's always some form of test. It's just a matter of, is the test automated? Is it written into code? Or is it just more like manually testing it? So I think we've already touched on that, but we'll just revisit again. Also, that's something we've talked about in the other video. In terms of testing, in my opinion, especially for projects that's in much smaller scope, most of the time the solutions are actually more straightforward, and then there are not really too much going on, like in terms of controller, a model. Rather, most of the time it's spent on like doing the templating, handling view rendering, that kind of thing. So in those cases, like for me, my thumb rule is that unit tests may not really be that needed. Whereas when a project gets more complicated, or it's a much bigger scope of work, then different components of the system start to interact with each other, and then they get usually the complexity dramatically increased. Then when we get there, then the unit tests become something that's actually beneficial and become handy. But otherwise, in general, like my thumb of rule is, if we got time, instead of writing like unit tests, I would prefer to at least have user story and cucumber tests, or the other term, acceptance tests, which basically hopefully at least test the heavy pass, where usually a user would follow, although user always breaks systems, right? But that aside, at least if the user followed the expected path or the expected inputs, the interaction, then they should get the right result, or we are getting the right or the desired behavior from the system. So, and then if we look at it from the other perspective, especially for the projects that you might get into in most of the ministries or for that, especially for new projects, it usually just starts relatively slow, and then it starts from a small user base, because it always takes time to build up a user base, and then in the early phase, depending on the project, sometimes it can take years before a site and application become popular or successful. Others may be quick, but still there is usually a beginning phase where even you break the system, it may not be too bad. It feels bad when someone talks to you that the site is down, this page doesn't work, or someone comes and goes, how can I do this and that, it doesn't work. It can feel frustrating, but from the business perspective, sometimes it may not be too bad. Also, for the second part, we will look at stuff from the project management perspective. So there's actually another type of workflow or project management methodology, which is, I forgot the term for that. It basically says define a goal, implement measurements, analyze it, and then do it, and then pivot. So if we do it that way, it actually, that pattern is more of like Devops. And then if we look at it from that perspective, or even just the operation perspective of it, if we have the right measurements, if we're always monitoring the application, and then have a mechanism to alert us if something goes wrong, then actually there can be times, and I actually encountered quite a few incidents like that, where some new changes, new release, break certain part of system, but because we are continuously monitoring the system, we can immediately catch the error, and then in a way, by having a system in production mode, like users, the real users are actually continuously and actively testing the application. So if we can always catch the error early, then especially for the beginning phase of most of the projects, it may not be too bad. So we catch it. Maybe one or two users encounter the error, but we have a monitoring system. We catch it. We either immediately roll it back if it's really bad. Otherwise, we can just keep it there as long as the error or the bug doesn't really impact too many people or too many users. Then we fix it and roll it out. Especially for web applications or SaaS applications, the process is pretty fast. It's not like traditional software or or even mobile apps where it takes at least a few days, to build it, ship it, and then sometimes need to go through a review process and wait for people, wait for it to be published on whatever platform it uses, and wait for user to actually click the update button to update the software. So considering that, especially for web applications or SaaS applications, like going without tests or automated tests, it's actually sometimes not too bad. But again, depending on the projects and how many users are using it and all that. So then if we then we step back. So that's the business side, the business perspective of a project. And from that perspective, tests are actually sometimes not as important. It may be actually okay to just break stuff, as long as we have a way to immediately find it and then fix it. But let's step back, and from the engineering perspective, so tests can still be useful, especially when it involves teams work, right? Tests can help us to tell, did the stuff that I changed break something else that the other person wrote it. And also for long term, does the change I made today break anything that's already there months ago? So from that perspective, test is indeed helpful, and then especially for projects that's expected to last long, or for projects that's expected to involve a large team, tests are still helpful. And then when we decide what type of test we want to prioritize, again, so we haven't decided if we want to test first, right? That aside, whether TDD or just traditional QA process, we still think about do we just do acceptance tests or the integration test or just unit test or module test? And then again, in my opinion, at least if time permits, at least do integration test or acceptance test first. That thing at least help us to make sure that what we're delivering, it actually meets the specification, or at least the happy path of the specifications. And then for me personally, I sometimes also write unit tests just to get certain points. There can be code, especially once something or some specific logic business has become pretty complicated, then when you want to debug those use cases, it can become tricky. Like you might have to open the browser, click this and then click that, and then check something, input some data, delete some data, and then open a page, and then the bugs start to present it, or then you can test a certain behavior or feature. So when we get to that point, that's usually when I start to write unit tests just to test that specific behavior, simply because it's pretty headache or it's a hassle to just go through all that in order to test the behavior. So just like what the professor mentioned in the video, if we if we do debug, or just in general, the conventional way to develop is write code, open the browser, and then see if the page render this is the right thing. You might want to print out some of the variables. It's actually not too bad compared to unit tests, right? Because unit tests, basically go to the terminal window or command line window, press up to get to the previous command, and then hit enter to run the test. And then actually sometimes when you have too many test cases, it can actually take pretty long to run all the tests. Although there are usually some way to just run one set of tests or one specific test. But that aside, compared to that, like just refresh the browser page, it's actually not too bad. It only gets bad when you have to like click one page, click the other page, click the third page, and check some checkboxes, and enter some numbers, whatever, and then click a little bit whatever. And then in order to reproduce again, you need to start all over. Then only those cases, then it starts to make sense to use unit tests to help you to speed up this process. So again, that's my opinion. My opinion is of course already different from the thing we watched in the video. But also again, for you can also have your own opinion. Just try it and then see how you feel about it. Do it in different projects and then see does the overhead. So basically, writing tests always has some sort of overhead. So does that overhead really make sense compared to the benefits or the good stuff you get from writing tests? But again, some of the other benefits are indeed true. It's just like it's a matter of the value. Do we weigh more on the benefits or do we weigh more on the overhead? And then going back, we haven't still talked about TDD. Do you test first or do you test later? And in my opinion, it really depends on the culture. It sort of makes sense if a company or a product is really tech-driven project. Then it sort of makes sense to make sure the code is maintainable, the project is maintainable, and then minimize the possibility of introducing bugs. But otherwise, like for example, if we're just developing a WordPress website, right? Like WordPress itself is already pretty much well tested, and then you probably don't want to test the behavior of WordPress itself. But then by using WordPress, it already comes with all sorts of pre-defined behaviors, and then the only thing that matters is actually like templating the pages. So yeah, sorry, go back. So do we do test first or do we do test later? In my opinion, it still makes better sense to me to test later, because then we always have the flexibility to just skip the tests when the schedule gets really tight, especially in a company or in a culture that technology is not really that much of a priority. But again, if in certain projects or certain cases when it makes sense to ensure or we do really value the tests, then TDD starts to make sense, because if you really commit to TDD, then by default you commit to tests, right? Because without tests you are not actually writing the code. Then by practicing TDD, we are basically committing ourselves to writing tests. Yeah, so that's some of my opinions on testing, and then TDD. And then again, that's something you could decide yourself, but I do encourage everyone to at least try it for some of your projects, and really feel it, and then come up with your own decision. All right, so we are basically done with TDD and testing. Now, since we have some extra time, we will watch some videos that basically look at software projects from the other perspective, which is project management. And then I think it's pretty important for software engineer or developer to also be able to understand the other perspective. So as an engineer or programmer like myself, in a perfect situation, for sure I want to write perfect system, write perfect code where there's completely no bug, or and prefer to have code that's perfectly beautiful, it's clean, but that's the perfect world. In real projects or real life, usually we don't have the luxury to perfect our code to achieve something like that. So that's why I think it's also important for engineers to also be able to see that from the other perspective. Sometimes it's just business decision, and sometimes we just need to trade off some of those technical perfection in order to achieve some business goals. So okay. So the materials are taken from this Coursera course. What you can do is you can just go to Coursera and then search project management, and you should be able to find this course. So from this week and then for the following weeks, if we got a chance, basically I will also play more videos from this course. Also, like for PM by itself, it could already be a separate course. So in this course, we will just give you a peek into PM, because it also affects what we do as software engineer. And then hopefully that can help you to really look at your projects from a different perspective, and hopefully it can help you to understand things. For example, like your boss or ministry leader will tell you to just like skip this function, or let's rush through that thing. When that happens, being able to look at projects from the other from the other perspective, it helps you to understand different decision-making principles. All right, so now without further ado, let's get to those videos.
Welcome back. Before we move on, let's recap what's already been covered. You learned how to define project management, what a project is, what it isn't, and how to explain its value to businesses. You also discussed when and why it's necessary to have a project manager, the role and day-to-day responsibilities of a project manager, and the core skills needed to be a successful project manager. Now's a good time to stop and recognize how much you've learned. By now, you're familiar with the job of project management, and you've started learning what it takes to be an effective project manager. Now you'll go a little further and learn some of the ins and outs of the job. And before you know it, you'll be ready to guide any project successfully. Are you ready? Well, coming up, I'll introduce you to the two most popular approaches to project management, Waterfall and Agile. We'll also cover the project management lifecycle and phases, and you'll learn about the different styles, scenarios, and factors that can impact a project and its tasks at any given phase. When we're done, you'll be able to explain and follow the life cycle of a project, define and outline a project's phases and each phase's tasks, compare different project management methodologies to determine which methodology is most effective for a project, and finally, organize how a project is run according to different program management methodologies. Ready? Let's get started. No two projects are exactly the same, which means there are many different ways to manage them. Each project comes with its own needs and factors that impact how you'll take action and achieve your goals. There are many ways to manage projects, and not always one right way to do so. Picture this. You're project managing a political campaign for a local candidate. To make it happen, you need to think about things like your available resources, the people you'll be working with, the election date, and the location. You need to be aware of lots of details to successfully complete your project. Because so many different things can impact a project, it's important to understand its basic structure. We call this structure the project lifecycle. The lifecycle is a great way to guide your project in the right direction so that you and your project stay on track and end up in the right place. Most project life cycles have 4 major phases, each with their own set of tasks and concerns. Check it out. The main phases of a project are initiate the project, make a plan, execute and complete tasks, and finally close the project. Let's talk about the first phase, initiate the project. This is the launchpad for the entire process of your project. In this phase, you'll define project goals and deliverables, identify the budget and resources you'll need, the people involved in your project, and any other details that can impact the successful completion of your project. You'll document all this information in one place to showcase the project's value, and hopefully get approval to move forward with it. Once the project is approved, it's time to get rolling. Next, you'll make a plan for how you'll meet the goals of your project. There are all kinds of ways to plan your project, and we'll get into some different methods and techniques later on. But right now, the important thing to know is that for every single project, creating a plan of how you're going to meet your goals is absolutely 100% essential. Think about it. You can't hire a contractor to build a house without planning what it'll look like or how much you have to spend. These same considerations apply to any project that you manage. To be effective, your plan needs to include a lot of things. For example, a budget, a breakdown of all the tasks that you need to be completed, ways to communicate team roles and responsibilities, a schedule, resources, and what to do in case your project encounters problems or needs to change. Now, that's just to name a few. Once you have your plan in place, it's time to execute and complete those tasks. It's important to point out that your project team has the job of completing the project tasks. Now, as a project manager, your role is a little different. While you might be in charge of completing certain tasks in the project, your primary tasks as the project manager are to monitor progress and keep your team motivated. You'll also remove any obstacles that might come up so that the tasks are executed well and on time. Finally, when all the tasks have been completed, all the resources have been accounted for, and the project has crossed the finish line, it's time to close the project. Why is it important to close? Well, one big reason is so your team has a moment to celebrate all of their hard work. But closing the project is also a chance to evaluate how the project went. You can make note of what worked and what didn't, so you can plan better for next time. Even if the project was a massive success, it's helpful to take time to reflect. Closing the project is also a great way to connect with anyone outside your team who may have had interest in the project's goal. You can let everyone know what was completed and what you accomplished. Some projects, like the campaign example, will have a firm end date, Once the project is finished, that's it. There's no more work to do. Other projects have different finish lines. For example, a project where you're implementing a new ordering system at a restaurant is complete after the system is set up and the employees know how it works. At that point, your goals are completed. Now it's time to hand over the project to another group whose job it is to provide support and make sure the system stays running on a day-to-day basis. Another example of this is, I once project managed the creation of a dashboard that would be used by various stakeholders in my organization. This dashboard would show pertinent information to each stakeholder depending on the team that they were a part of in our broader organization. I project managed the beginning, from writing out the vision for the project, to the end, where we delivered the dashboard. Now, once I passed off the final product, I transitioned the continued update of each team's data and the corresponding dashboard page to the respective teams. Think of it like turning over the keys of a newly built house to its new owner. The project of building the house is complete, and now it's up to the owner to take care of the house's maintenance and the upkeep. So there you have it. The project lifecycle. The exact name for each phase might change depending on the type of project or organization you work for, but the general idea stays the same. And following the project processes you will learn in this course will set you up for project management success. Next, we'll take a closer look into what happens during each phase of the traditional project lifecycle. Now that we've discussed the project lifecycle, we're going to explore some of the different tasks that match up with each lifecycle phase. But first, let's review the phases. The project lifecycle phases are: initiate the project, make a plan, execute and complete tasks, and close out the project. Okay, great. Let's get back to the tasks that need to be accomplished during each phase. For this video, we're going to focus on the first two project lifecycle phases: initiating the project and making a plan. It's important to call out that the name or tasks for each phase might change or may be a little different depending on the type of project or the organization where you work. At Google, we use a mix of different project management methods, which you'll learn more about later in the course. But regardless of the method, all projects share a lot of the same tasks needed to get the job done. So let's get into it. The first step of the project lifecycle is to initiate the project. During initiation, you'll organize all of the information you have available to you about your project. This way, when you're ready to continue on, you'll be prepared for the next phase when you can create your plan. Defining project goals makes the details of your project clear so that you and your team can successfully complete the project. For example, if the project goal is to manage a political campaign, then some deliverables, which are specific tasks or outcomes, might be to raise $5,000 or get 500 signatures in support of your candidate's cause. With this in mind, you'll need to do some research to come up with ideas that will help you meet your goals. You'll also need to find out what resources are available. Resources can include people, equipment, software programs, vendors, physical space or locations, and more. Anything you need to actually complete the project is considered a resource. You'll record all of these details in your project proposal, and then get them approved by a decision maker or group of decision makers at your company so that you can move ahead with your project plans. Now, in some cases, you may be the decision maker, so be sure to consider the same set of factors when initiating your project before moving to the next stage. No worries, you will learn all the details about how to create a project proposal. We will be getting into more detail of what this is and how to create one later in the course. Voila! Once your project is approved, you'll move into the second step of the project lifecycle, which is to make a plan. In this phase, you'll create a budget and set the project schedule. You'll establish the project team and determine each person's roles and responsibilities. Let's pause for a second. You may be thinking, Why can't we just get started? But that's the thing with project management. Deliberate planning is critical to a project's success. A crucial part of project management is planning for risk and change. An experienced project manager knows that plans always change. This ability to adapt is all about thinking and planning ahead. Scheduling delays, budget changes, technology and software requirements, legal issues, quality control, and access to resources are just some of the more common types of risks and changes that a project manager needs to consider. So it's important to keep in mind that planning is key to reducing those risks. But don't worry, if the idea of risks seems a little overwhelming right now, in later courses we'll teach you all about understanding risks. Just know that it's really important not to skip this step and to always make a plan. Again, the success of your project depends on it. Once you have a plan, you'll communicate all of this information to your team. That way, each member will know which tasks they'll own and what to do if they have questions or if they run into problems. You'll also communicate your plan with others who have an interest in the project's success, so that they are aware of your plans and your progress as the project continues to move forward. Nice job! We've made it halfway through the steps of a project lifecycle. Up next, we'll check out the remaining 2 phases: executing and completing tasks and closing the project. Catch you in a bit. Welcome back. We just learned about the core tasks that need to be completed in the first 2 phases of the project lifecycle: initiating the project and making plans. Now, it's time to put your plans into action. Remember, it's not your job to actually do all the tasks. Your primary job as the project manager is to manage the progress of the project as a whole. This means you'll oversee your team's efforts and make sure everyone understands what's expected of them, what tasks need to be done, and how and when to complete those tasks. It's also your job to help remove any obstacles and to alert the right people if it looks like there might be a delay to the project. This means you'll need to communicate with your team and anyone else involved in your project through meetings, written communications like memos, emails or internal chat tools, and other working documents like task reports. Quick pro tip: if in doubt, err on the side of over-communication. As your project progresses, you'll make adjustments to the schedule, budget, and allocation of resources, clearly communicating updates all along the way. When all the tasks are complete and you've met the project goal, it's time to close the project. This phase is usually overlooked because it's easy to assume that once the project goal has been delivered, everyone can move on. But hold up. There's still a lot that needs to be done. First, check to make sure all tasks have been completed, including any work that was added along the way. Be sure any outstanding invoices have been paid, resources are returned and accounted for, and project documentation has been submitted. Next, and this is very important, get confirmation that the final outcome of your project is acceptable to the people you're delivering it to. It is crucial to your project's success that the person who asked you to manage the project is satisfied with the end result. Once your project has been accepted as meeting its goals, take some time to reflect on what went well and maybe what didn't go so well. This reflection is usually called a retrospective, and it's a chance to note best practices and learn how to manage a project more effectively next time. Even if everything went great, the notes from your retrospective are also valuable to the people or organization receiving the end result of the project. That's because they can use that information to inform decisions about their business the next time they consider a project. Now it's time to collect all the project documentation that you've created or collected along the way, including all of your plans and reflections, and share the final results of your project with your stakeholders. Remember, stakeholders are people who are interested in and affected by the project's completion and success. Depending on the type of project, stakeholders could include a department or organization's management team, clients or customers of your product or service, users of your new tool or process, or even the community at large if you're planning a community town hall meeting. Pro tip: stakeholders play a huge role in the development and success of your project. You'll learn a lot more about these key players later on, but for now, just know that they are like the VIPs of your project. Next, take some time to celebrate the effort your team invested in the project. Celebrations help people feel good about the work they've done, and think of the work as uplifting and rewarding because it truly is. Some ideas for small celebrations are a company or team-wide email, thanking the team and acknowledging individual efforts. Now, for big projects, you may even consider a company party to celebrate the team and the project's success. To wrap up, you and your team can formally move on from the project so that you can pursue new projects in the future. Well, as you can see, being a project manager is a lot of work, but it's very rewarding, and it's all, well, manageable when you follow through with the project lifecycle. You can see how the organization, communication, and improvements you add to various areas of a project can make the entire team more effective and efficient. And you can have an impact on many areas of a project in a way that's greater than if you focused on any one task on the project. Similar to a coach with a sports team, even though you aren't actually playing a direct role in the game, your guidance, your communication, and your team building can make the difference in a happy, high-performing, and successful team. In later courses, we'll discuss each of these project phases, and you'll learn methods, techniques, and tools to help you. For now, we just want you to become familiar with the general project management process, and we'll share some of the terms and concepts used in the field that you'll need to know as you develop your project management skills. Up next, we'll introduce you to two of the more popular project methodologies, Waterfall and Agile. See you soon.
Okay, quick pause right there. We've now been introduced to the four major phases for pretty much any project life cycle. It's just a matter of we've been talking about Agile versus Waterfall. Although it's different practices or different methodology, it's still pretty much the same when we look at from the life cycle perspective. It's just for Agile, we're doing it in a much more shorter window for each pivot or for each cycle. But regardless, it still goes through, ideally, if a project is well managed, it should still go through initialization phase where we kickstart the projects, everybody understands goal, and then establish the communication. And then, regardless. And then planning phase, like for Agile, 2 weeks ago when we look at BDD, it's pretty much planning, doing the planning in a pivotal tracker, where we break it down by tasks and then make estimates and then assign the tasks to each individual, and then for each pivot or each sprint, or if it's Waterfall, it's basically the entire schedule. Whatever time we know we can fit, then we fit the tasks based on priorities and estimations. So that's roughly what we're talking about for the planning phase. And then if we actually look at that from the project perspective, estimates become something that's really important, right? So for project management, the major three the three major factors or elements of project management is time, resource, and then deliverables, right? It's basically trading off. I mean, also there are like risk management and all that, but that aside, the major thing is the trade-off between these three elements. Because of course, if we get more time, we can get more stuff done, and then if we get more people, we can also get more stuff done. But then if the time and the people or resources is limited, then that limits the deliverables. So then for project management to be able to schedule things well, or to arrange the time schedule and then arrange the resources, what's important is for them to have some, of course, accurate estimate would be great, and then that's why in the pivotal tracker video we introduced the concept of assigning points, because human beings are basically bad at making estimates. So instead of estimating time, like oh, this task would take a week, we estimate the point. Oh, this is 4 points or 2 points compared to the other simple task, which is 1 point. Relatively, it's actually easier for people to make estimate that way, and then have a system to track the points and see like each point is equivalent to how much time, right? So that was the idea, but also step one step back. Even if we don't do like the points system for making estimates, but just looking at project management, it's still important to make estimates, even if it's not accurate, right? So actually the other way, without point system, like we could use like time ranges, instead of saying, oh, this one is gonna take a week, we could say, oh, this task is probably gonna take half week to 2 weeks, between this range. And usually if we do that, that's possibly a better, it has better accuracy, because it's a range of time rather than just a very specific date. And even that, with that, project management can still arrange the schedules, and sometimes it actually do make sense to make an estimate that way, especially for tasks that's still uncertain, like some technical part that we don't fully understand yet, or some solution that we don't clearly see. Sometimes it actually makes sense to do that, and then sometimes the situation may be worse, where like we just simply don't know the solution, or it's really just a research process, or like for a bug, it can be a really mysterious bug sometimes, that you don't even know where to start. In those cases, it's still better to make some sort of estimate rather than just say, oh, I'll try my best and then see. Yeah, I mean, for programmer, or from the technical perspective, yeah, it makes sense. Yeah, and it is true that we don't know sometimes, but from project perspective, because it's always well, projects always live in the time window, so it has to have a clear cut in terms of time. So rather than just say, hey, we don't know, we could say something like, oh, maybe we could try to fix it in a week, and then if we still cannot fix it in a week, we might just give up for now. So that way, a task can still be sort of time bound, because if we just say, oh, we'll try our best, and then no clear estimates, it's just going to be really tough for project manager to arrange resources and time. So okay, So that's enough comments. Yeah, so what I want to say is I've actually seen programmers and developers who just don't communicate that well. I mean, that's also part of personality, I guess. But in my opinion, in order to be a good developer, a good software engineer, even if it may not be your personality, you may not be that type of person. I mean, even for me, I guess like 10 years ago, before or even after I came to Jesus for a bit, I was still a really shy guy, and I don't really talk too much. I mean, even today I don't talk too much, except in those cases that I need to talk. But anyway, back then I was like really shy, and then I don't really talk, and I really don't want to talk. But really, I think for a person to become a good engineer and developer, even if it may again be something against your personality, and I think on average it may be because developers are usually thinkers, who just think, and then a lot of stuff going on in their head rather than talk it out. But anyway, what I want to say is even maybe you don't really want to communicate, or maybe you are too busy to communicate. But I want to say, from the project perspective, it's still really important for a programmer to see the value of communication. And like we've talked about making estimates, yeah, it's also important to be able to clearly communicate your estimate. Even if you cannot make any estimates, it still makes sense to say something. Oh, we can try within a certain time window, rather than just say, okay, I will do whatever. Yeah, that's what I want to talk about. So now let's continue with our videos for project management. So we will basically revisit the waterfall methodology versus agile methodology. So for the course so far, we've pretty much always been talking about agile, but we'll also take a brief look at waterfall, or in the other videos, they've been calling it plan and documentation, which actually they are referring to waterfall. So I don't know why they call it plan and documentation. It actually doesn't really make sense, because even for agile, we're still planning and making documentations, right? Like by doing the pivot tracker, we're planning what tasks to do, and then the schedules. And then for documentation, like for writing cucumber tests, writing user stories, and then developing or drawing out those wireframes. And what's the other mock-up? These things those are actually documentation. So yeah, I don't really think it should be called plan and documentation. They should really just call it waterfall. But anyway, so for the next video, we'll look at waterfall and agile, and then there are some other methodology this course will introduce us later on. So now we will resume the video.
Welcome back. As we've already discussed, not all projects are alike. Different types of projects will benefit from applying different project management approaches or methodologies. A project management methodology is a set of guiding principles and processes for owning a project through its life cycle. Project management methodologies help guide project managers throughout a project with steps to take, tasks to complete, and principles for managing the project overall. We will talk through two different types, linear and iterative. Linear means the previous phase or task has to be completed before the next can start. A linear approach would work well for a project like building a house. You'd need the blueprint created before you can begin laying the foundation. You've got to know exactly what the house will look like, its dimensions, and what type and how many resources you'll need. Then you've got to finish the foundation before you put up the walls, and the walls before you put up the roof. and so on, before you have the finished project, which is a bungalow-style home. There's also a clear goal. You know exactly what the house will look like. It's unlikely that in the middle of building the house, your client is going to decide they'd rather have a multi-level Victorian instead of a single-level bungalow. What's more, even if they wanted to change, it's too late. You already laid the foundation and built the walls for the bungalow. Done and done. A bungalow is what they wanted, and a bungalow is what they'll get. Using this type of linear project management approach, completing each step in order and sticking to the agreed upon specific results and being able to deliver just what the client ordered. For a project like producing a new show for a television company, on the other hand, it might be more effective to use a methodology that uses an iterative, more flexible approach, where some of the phases and tasks will overlap or happen at the same time that other tasks are being worked on. Your team comes up with an idea for a show and films a pilot. You run several tests of the pilot in different locations and time slots. As your team gathers feedback about the pilot, adjustments to the show are made. At the same time, you're able to make decisions and start working on other parts of the project, like hiring permanent actors, starting film production, and working on advertising, even while the final version of the show is being worked on. And even though the overall goal is clear, produce a new show, the type of show could end up being different from the original idea. Your team may have started out creating a 1-hour show, but during testing, they realized a half-hour show would actually be more popular. Or maybe a supporting character got a lot of positive feedback, so you want to make them one of the main characters. What's more important is that you produce a show that audiences are going to watch. Because of the iterative approach, plans remain flexible, and you're able to make adjustments as you go along. Each of these projects benefits from a different approach to how tasks will be carried out in order to best meet the project's goals. Linear projects don't require many changes during development and have a clear, sequential process. If you stick to the plan, it's likely you'll finish your tasks within the time schedule and all other criteria. Iterative projects allow for more flexibility and anticipate changes. You're able to test out parts of the project to make sure they work before the final result is delivered. And you can deliver parts of the project as they are completed, rather than waiting for the entire project to be done. Over the years, the field of project management has developed many different methods that project managers can choose from that will help them manage most effectively. Google takes a hybrid approach to project management. We mix and match from different methods depending on the type of project. Our project managers are encouraged to adapt their own style to what makes the most sense to their project and their team. So are you starting to see how different approaches might benefit the projects you'll be working on now? Pretty soon, you'll become a pro at picking an approach or combining approaches to fit with your project. Up next, we'll learn about the most well-known and most used project management methods that you can add to your project management toolbox. Two of the most popular project management methodologies are Waterfall and Agile. Each of these methods has a rich and complex history. In fact, you could take an entire certificate on just one of these methods alone. You'll have a chance to learn more about Waterfall and Agile methods in the upcoming courses of this certificate. So be sure to check those out after completing this one to learn more. For now, I'll just give you a brief introduction and provide you with some examples that illustrate how different types of projects can be more successful or easier to manage when you consider which method to use. First, let's take a look at the Waterfall approach. Waterfall, as a methodology, was created in the 70s and refers to the sequential ordering of phases. You complete one at a time, down the line, like a waterfall starting at the top of a mountain and traveling to the bottom. Remember the definition and example of linear from that last video? Well, Waterfall has a linear approach. At first, Waterfall was used in the physical engineering disciplines, like manufacturing and construction. Then software emerged as an important field of engineering, and Waterfall was applied to those kinds of projects as well. It's still used a lot in engineering fields, including product feature design and application, also known as app design. Over time, other industries like event planning and retail have adapted waterfall phases to fit their projects. There are now many styles of waterfall, and each style has its own specific set of steps. What they all have in common, though, is that they follow an ordered set of steps that are directly linked to clearly defined expectations, resources, and goals that are not likely to change. Let's take a closer look. The phases of a waterfall project lifecycle follow the same standard project lifecycle flow that you learned about earlier: initiating, planning, executing, which includes managing and completing tasks, and closing. So, when would you want to use a waterfall approach to project management? Well, when the phases of the project are clearly defined, or when there are tasks to complete before another can begin, or when changes to the project are very expensive to implement once it's started. For example, if you were catering an event for a client on a very tight budget, you might want to use waterfall methodology. This way, you could confirm the number of guests first, then very clearly define the menu, get approval and agreement on the menu items and costs, order the unreturnable ingredients, and successfully feed the guests. Because the budget is limited, you can't afford to make changes or waste food. The traditional method won't allow for the client to make changes to the menu once the order has been placed. You can also reserve tables, chairs, and dishes because you know exactly how much and what kind of food is being prepared. A well thought out traditional approach to managing a project can help you reach your desired outcome with as little pain as possible during the project implementation. By spending extra effort thinking through the entire project up front, you'll set yourself up for success. Now, in an ideal world, following this approach will help you identify the right people and tasks, plan accordingly to avoid any hiccups along the way, create room for documenting your plans and progress, and enable you to hit that goal. However, plans don't always go, well, according to plan. In fact, they rarely do. The waterfall method has some risk management practices to help avoid and deal with project changes. Luckily, there are other methodologies that are entirely built for change and flexibility. One of these is Agile, another popular project management approach. The term Agile means being able to move quickly and easily. It also refers to flexibility, which means being willing and able to change and adapt. Projects that use an Agile approach often have many tasks being worked on at the same time, or in various stages of completion, which makes it an iterative approach. The concepts that shaped Agile methodology began to emerge in the 90s as a response to the growing demand for faster delivery of products, mainly software applications at that time. But it wasn't officially named Agile until 2001. The phases of an Agile project also follow the project lifecycle stages we described earlier, generally speaking. However, rather than having to always go in order or wait for one phase to end before starting the next, Agile project phases overlap and tasks are completed in iterations, which in Scrum are called sprints. Scrum is a form of Agile that you'll learn more about in the course focused entirely on Agile. And by sprint, we do not mean running a race as fast as possible. In this case, sprints are short chunks of time, usually 1 to 4 weeks, where a team works together to focus on completing specific tasks. What's important to understand is that Agile is more of a mindset than just a series of steps or phases. It's concerned with building an effective collaborative team that seeks regular feedback from the client so that they can deliver the best value as quickly as possible and adjust as changes emerge. Projects that are best suited for an Agile approach are those where the client has an idea of what they want, but doesn't have a concrete picture in mind. Or they have a set of qualities they'd like to see in the end result, but aren't as concerned with exactly what it looks like. Another indicator that a project may benefit from Agile is the level of high uncertainty and risk involved with the project. We'll talk more about those things later. An example of a project that would work well with an Agile approach might be building a website. Your team would build the different parts of the website in sprints and deliver each part to the client as they are built. This way, the website can be launched with some parts, say the main homepage, that are complete and ready for public view, while other parts, maybe the company blog or the ability to book online appointments, continue to get built out over time. This allows the team to get feedback early on about what works and what doesn't, make adjustments along the way, and reduce wasted efforts. In this same website example, the waterfall method will plan for and require the whole website to be complete before it can launch. Having a basic understanding of Waterfall and Agile will help you figure out an effective way to organize and plan out your project. And knowing about these two methodologies will come in handy during future job interviews, because you'll be able to demonstrate a solid understanding of the project management landscape. Waterfall and Agile are two of the more common and well-known project management methodologies, but they are by no means the only or the best ones. In the next videos, you'll learn about Lean Six Sigma, another way to approach projects. Here at Google, believe it or not, we select from many of these methodologies for project management. Hey again, now you've got Waterfall and Agile methodologies in your project manager toolbox. Lean Six Sigma is one more you can add. It's a combination of two parent methodologies, Lean and Six Sigma. The uses for Lean Six Sigma are common in projects that have goals to save money, improve quality, and move through processes quickly. It also focuses on team collaboration, which promotes a positive work environment. The idea is that when your team feels valued, motivation and productivity increases, and the whole process functions more smoothly. There are 5 phases in the Lean Six Sigma approach. They are define, measure, analyze, improve, and control, commonly known as Dmaic. Dmaic is a strategy for process improvement, meaning you're trying to figure out where the problems are in the current process and fix them so that everything runs more smoothly. The goal of each step is to ensure the best possible results for your project. Just like with Waterfall and Agile, there are more specific details for using Dmaic and the Lean Six Sigma approach. But what's great about the Dmaic process is that it can be used to solve any business problem. Let's break it down. The first phase is to define the project goal and what it will take to meet it. This first phase is very similar to the initiation phase of traditional project management. Let's take a real scenario to illustrate. Imagine that you are brought on as a project manager for a large travel company to help streamline and minimize customer service wait times that have been surging due to a recent sales promotion. Before you begin working on tackling the issue, you're going to need to define the project goal and talk to stakeholders about expectations for the project. In this case, the goal is to take average wait times down to less than 10 minutes on average compared to 30 minutes. Next, it's time to measure how the current process is performing. In order to improve processes, Dmaic focuses on data. Here you want to map out the current process and locate exactly where the problems are and what kind of effect the problems have on the process. Using our example, you're trying to figure out why it's taking so long for the travel company to address a customer service issue. To do this, you look at company data like average wait times, number of customers per day, and seasonal variations. Then you'll set a plan for how you'll get that data and how often to measure it. This could look something like having the company generate reports on a weekly, monthly, quarterly basis. In other situations, you might have employees or customers fill out surveys or look at inventory shipping and tracking records, things like that. Once you have the data and measurements, you can move on to the next phase, which is analyze. Here, you'll begin to identify gaps and issues. In our example, after mapping out the process and data points, you may see that staffing is inadequate on days where customers are the highest. Data analysis is important for project managers regardless of which method you choose, and we will learn more about that in an upcoming course. From your data, you'll have a strong understanding of causes and solutions to get to the next stage. Improve. Oftentimes, project managers may want to leap straight to this phase, but really, projects and process improvements should only be made after a careful analysis. This is the point where you present your findings and get ready to start making improvements. In our example, this could be modifying staffing to address customer needs. The last step of this cycle is control. You've gotten the process and project to a good place, and now it's time to implement it and keep it there. Controlling is all about learning from the work you did up front to put new processes and documentation in place, and continue to monitor so the company doesn't revert back to the old, inefficient way of doing things. To sum it all up, you can remember DMAIC like this. Defining tells you what to measure. Measuring tells you what to analyze. Analyzing tells you what to improve, and improving tells you what to control. Lean Six Sigma and the DMAIC approach are ideal when the project goal includes improving a current process to fix complex or high-risk problems, like improving sales conversions or eliminating a bottleneck, which is when things get backed up during a process. Following the DMAIC process prevents the likelihood of skipping important steps and increases the chances of a successful project, and is a way for your team to discover best practices that your client can use going forward. It uses data and focuses on the customer or end user to solve problems in a way that builds on previous learning so that you can discover effective permanent solutions for difficult problems. There are many ways out there that break the flow of project management into digestible phases and approaches, all with the same end goal of accomplishing the desired outcome as smoothly as possible and delivering the best value. Like I said earlier, at Google, we follow a lot of different approaches. For instance, an engineering team releasing a customer-focused product may primarily use Agile when creating the product, but decide to plug in some of the aspects of Waterfall project management for planning and documentation. A customer service team might focus on using Lean Six Sigma to improve an experience for our users, like offering new features based on a recent analysis. But the team might develop parts of the code and roll out the features using agile iterations and sprints to allow for change. Or one of our internal education and training teams may focus solely on Waterfall project management to achieve a targeted goal of having all employees complete an annual compliance training. Here, Waterfall makes sense since the requirements of the training program are fixed, and so is the deadline and goal. The biggest takeaway is to know the various methods and tools to be able to confidently apply what works best for you, your team, and the end goal. There is no real prescription for how to execute a project perfectly, because there are always pieces you can't 100% control. But the good news is, you can get pretty close with the skill sets you develop through learning about these different frameworks. Congrats on completing this module on the project lifecycle and project management methodologies. So what did you think? Hopefully, this introduction to a few of the core project management methodologies and hearing from a Googler about the way we approach project management here at Google has you interested and excited to keep on learning. One of the great things about project management is that it can be really creative and present you with challenging problems to solve that have a rewarding impact. You get to work with teams full of interesting, skilled, and dedicated people who help with the problem solving and idea generating process. Every project is an opportunity to learn and try something new. Waterfall, Agile, and Lean Six Sigma are solid foundations from which to build your understanding of project management. Each methodology has its own set of rules, values, and processes. There is no such thing as a right or a wrong methodology. There is no one-size-fits-all approach to take. And there's almost no limit to the number of ways you can blend different approaches to fit the needs of your project. Your goal in choosing a methodology is to maximize the use of resources and time. The method, or combination of methods, will help you reach your goal in the most efficient and effective way. This might feel like choice overload right here, but hang in there. With time and practice, you'll become more comfortable with the benefits and limits of different methodologies, and you'll be able to approach your project assignments with confidence. Next, you'll build on these foundations by learning how an organization's structure and culture can impact the way you manage your project. See you soon.
Alright, so that's all the videos for today. So yeah, just want to revisit on the last video where we introduced one additional methodology, which is Lean Six Sigma, or the AIC, whatever. I just can't remember that acronym. But anyway, like later we will be introduced to practices like Devops, although the tools that Devops uses are like automation, configuration management, and all that. But actually, the principle behind it is actually very close to Lean Six Sigma, where we define the thing to measure, right? Like for Devops, actually, I'll just skip that. 2 weeks, I think it's 2 weeks later. We'll talk about Devops, and then we'll probably notice that it's pretty much following the principle of Lean Six Sigma, where we define the measurement, we measure it, and then we continue to monitor it, and then continue to improve based on the measurement. Because the pitfall is always just making improvements where that you think it will improve stuff. But cases are without measurements, you actually cannot really tell the changes you made actually made any improvement. Hopefully that makes sense. Anyway, we will talk more about that later in this course. So that will be it for today, since we don't have long enough time to have a practice session. So I guess we will just end a few minutes early. Okay, so just emphasize again for the homework this week. So you can find the homeworks here. Either write a summary or do the chips or hand-on homework. And then I've already made a correction at the beginning of this video. So just forget about what I talked about last video or last lecture, where I actually used the wrong link. My brother for RSpec and TDD used the updated link, and that's the code base you work on if you choose to do hands-on homework. All right, so then that will be it for today. See you next week. Bye.